What's up, 6th grade? This is Lesson 10, Day 2, and you're going to be multiplying some nasty big decimal numbers today. So let's start. Make sure your math book is on page 104. If not, go get it. If you have it, let's start by reading this problem at the top, and then you're going to explore it. So it says, 4 6th graders are working on a project. They are going to paint a large banner, and they need to protect the floor. They measure the floor, which is 3.05 meters by 3.658 meters. How many square meters of plastic do they need to cover the entire floor? Now, by the way, let's talk about why this is a multiplication problem. So notice they give us 2 dimensions. They measure the floor, which is 3.05 meters by 3.658 meters. And it's asking for how many square meters of plastic they'll need to cover the floor. Well, this is an area problem, so if it's area of a rectangle, it's length times width. So you're going to multiply the length and the width. But here's another way. You see how they say it is 3.05 meters by 3.658 meters? Whenever you see a problem and they use the word by, that means multiply. Because another way to write it is 3.05 by 3.658. So if you know by means multiply, then you know that right up front. So here is what you are going to do. In a minute, you are going to explore the estimate it, the first model which is all about just placing the decimal point based on the denominators, and the second model it, which the book has you doing just the traditional way, but I'm going to also have you do the lattice problem. All right, just for both people. So now, y'all have that, and let's go over here. So what I want you to do first is start the connect it. It says you use what you know about decimals and place value to solve the problem. So these problems are going to guide us one step at a time through solving that problem on the other page. So first thing I want you to do is 2 and 3. So 2 is looking at the estimate it, and 3 is looking at the first model it with the fractions. When you're done with 2 and 3, restart the video, and you can go over it with me. All right, go. Okay, let's see how you did for 2 and 3. So 2 says look at estimate it about how many square meters of plastic will they need. So if I go back over to the estimate it, here's what they said. They said 3.05 is about 3. 3.658, because that 6 is 5 or higher, rounds up to 4. So if you will need about 3 times 4, or 12 square meters of plastic. So going on back to this page, how many square meters of plastic will they need? About 12 square meters. All right, if you didn't have square meters, make sure you label it. Now, if you had that, so far, so good. 3 says, look at the first model it. What will the denominator of the product be? So let's go look at that one. So in this model, let me explain what they're doing. They are saying that you can write these two amounts as fractions. So let's go through the steps. This says 3 5/100 can be written as a mixed number, 3 5/100, or 300 5/100. This one can be written as 3 658 thousandths, or 3 658 thousandths, or 3,658 thousandths. Now, if you take these two numbers and multiply them, you'll see down here. Don't worry, you're not going to do those two problems, 305 times 3,658. But they are saying, what will the denominator be? So if you do 100 times 1,000, you write the 1 and you count the zeros. There's 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So my denominator is going to be 100,000. So when I go back over here, what will the denominator of the product be? 100,000. Now keep this in mind, because this could help us place the decimal point in a little bit. So if you had 2 or 3 wrong, make sure you pause the video and correct it before we go on to number 4. All right, so now here is your next job. In number 4, it says look at the second modelet. How many decimal places will be in the product? How do you know? All right, so now I'm going to guide you through this one a little bit. When you look at the second modelet, we want you looking at the problem here. And notice here was what they're saying. The first number, I'll switch to blue, has 3 decimal places, 1, 2, 3. So that's what they're saying here. The second number has 2 decimal places. That's what they're saying here. So you can use that, or you can use our estimate from number 3 to figure out where the decimal place will be. So what I want you to do is I want you to answer number 4. Okay? Pause the video. When you're done, restart it and see how you did. Go. All right, let's see how you did in number 4. So it says how many decimal places will be in the product? How do you know? So first thing, I'm going to answer the question. There will be 5 decimal places. Now, I'm going to explain how I know, but my question is, did you have 5 decimal places? So let's go back and I'll explain how I know. Remember here are 2 factors. Each have, one has 3 decimal places and one has 2. That means our answer is going to have 5 decimal places because 3 plus 2 is 5. That's how you get it. So when I go back over here, I'm going to say there will be 5 decimal places. I know this because both factors, remember factors are the numbers you multiply, have 5 decimal places. Okay. So if you add the answer right and you explained it somewhere in your own words, you're good. If not, you know you have to change it so you don't have the wrong answer. Now, number 5, it says add the partial products and make the decimal point and place the decimal point in the product in the second modelet. Does your answer make sense? So let's go look at what you're going to do. Now, you are going to add the partial products. Now, here's what they mean by the partial products. The partial products are these numbers you get down here. So they did all of the multiplying for you, the 5 times everything, the 0, and the 3. So you just need to add those partial products. Now, after you get your answer down here, place your decimal point. Remember, this tells you how many decimal digits you're going to have. Now, then, when it says, does your answer make sense? Remember your estimate up for problem 2. If your answer is not anywhere close to 12 square meters, it's not going to make sense. If it is close to 12, your answer will make sense. All right, so are you ready? Pause the video. Do number 5. When you're done, restart it. Go. All right, so let's see how you did. So first in number 5, I'm going to add the partial products and place the decimal. Now, before I do this, let me erase this here. Remember my estimate was 12 because I did 3 times 4 up at the top. So now let me add my partial products. So I start with 0, 9 and 0, 9 and 0 is 9, 4, 0 and 2 is 6, 7 and 8 is 15, write the 5, carry the 1, 9, 10, 11, write the 1, carry the 1, I have a 1, and then another 1. So do you have those digits, 1, 1, 1, 5, 6, 9, 0? All right, so now I'm going to place the decimal point. So remember, my 2 numbers I multiply, my factors have 3 decimal places. So that means my answer, my product, needs to have 5 decimal places. All right, see how I have 5 after? Now, does my answer make sense? If I put my decimal there, my answer is 11.5. 11.15690. Is that close to 12? Well, yeah, I'd say 11 is close to 12. So yes, it's going to make sense. Now, let me show you something else which I think is kind of cool. Let me undo all this stuff. Let's say you don't know where to put your decimal point, but you have all these digits, 1115690. If you know your answer's got to be close to 12, well, you have to put your decimal point somewhere where your answer's close to 12. How about there? No, that's close to 1. It's not close to 12. How about there? No, that's close to 111, so that's not a good place. Now, if you use your common sense, you're like, okay, if I put my decimal here, 11 is really close to 12. Well, that's a good way to place your decimal point. So now, let me go back and answer the question. I added my partial products and I placed the decimal point. Does your answer make sense? And yes, it does. And I'm going to say because my answer is close to my estimate. Okay, that's how I know my answer makes sense. Now 6, before we do 6, explain how to multiply decimals. I want to go back and I want to show you lattice. Now I'm going to give you an option here. If you are not a lattice person, you don't have to do this with me, but if you are a lattice person, you're going to want to pause the video and get your lattice set up. You can pause it now, and when you get it drawn like it is, you can restart. All right, so now let me show you lattice. So what I'm going to do is I'm going to fill in, I'm going to multiply and get all of the digits in the boxes. So let me get my pen ready. I'll switch to red so you guys can see, and get my pen as thin as possible. Okay, so now I'm going to start with the 3 times everything. You ready to go? 3 times 8 is 24. 3 times 5 is 15. 3 times 6 is 18. And 3 times 3 is 9. Next, I'm going to multiply the 0 by everything. Now that's easy because everything is going to be a bunch of zeros. But you want to see a cooler trick? If they're all zeros, just leave that row blank. There'll be less numbers to look at when you're adding. Now I'm going to multiply 5 by everything. 5 times 8 is 40. 5 times 5 is 25. 5 times 6 is 30. 5 times 3 is 15. Now you might be thinking that's a lot of work, but remember, you would have had to do all of that multiplication to get these numbers. The book was just so nice to do those for you. But now, I'm going to add up my diagonals. So I get 0, 9, 6. So this is 5 plus 3 is 8, plus 5 is 13, 14, 15. Right, the 5 carry the 1. So 1 and 1 is 2, 3, and 8 is 11. I have 9, 10, 11, and 1. So notice I get the same digits, the 1115690. Now, what I think is fun about lattice is it gives you another way to place the decimal. You can still use the same thing, count the decimal digits, estimate, but this gives you another way to do it. So what I'm going to do is show you. So watch how this works. I think this is fun. Let me get a thinner pen. All right. So, see this decimal right there and this decimal right there. If you see where they meet, so this decimal comes down there and this decimal comes over here, they make an L. See how that makes a green L? And then the L points down this diagonal line, and that's where your decimal point's going to go. So you know it's going to be 11.15690. So I think placing decimals in lattice is kind of fun once you get used to it. All right, so now let's go back over here. You are now going to explain how to multiply decimals. So in your own words, I want you to write simply your explanation. So just so you know, as a review, we did the traditional way, we did a lattice, we did some estimating, we did lots of things to help you explain it. So 2 to 3 sentences, and then That's it. Restart the video when you're done. Pause it. Do number 6. Go. All right, so let's see how you did for number 6. So here's all I'm going to say. So when I multiply decimals, so I'll say first, I multiply the decimals just like I do whole numbers. Okay, so I multiply the numbers just like whole numbers. So when you do the multiplication, it's no different than whole numbers. So the only thing that's different is when you place your decimal. So next, place the decimal so that your answer has the same number of decimal places as both products. So you count up the decimal places in both products, and then you make sure your answer has the same number of decimal places. All right, so if you put it in your own words, then you should be good to go. If you were wrong, that's where you can fix your answer. Okay, so now, here's what you're going to do. We are going to kind of start number 7 together, and then we'll have you try 8 on your own. So in the try it section, it says, use what you just learned about multiplying with decimals to solve these problems. Show your work on a separate sheet of paper. All right, if you have no room, get a separate sheet of paper. Okay, so you're ready for number 7. Let's read it. It says, Madeline studies honeybees. Every week she weighs the same honeybee hive. The first week the hive weighs 11.607 kilograms. So I'm going to underline that. So week 1, the hive weighs 11.607 kilograms. Now, next, it says its weight increases about 0.204 kilograms every week. At this rate, how many kilograms will it increase in 7.5 weeks? All right, so here's what I know. To figure out how many kilograms will it increase in 7.5 weeks, I have to do this. Its weight increases 0.204 kilograms every week, and it's doing that for 7.5 weeks. So I'm going to multiply these two numbers together to get my answer. Now here is your option. You could do it traditional. You can do it lattice. You can do, I don't know, do whatever you want. Just don't use a calculator. I will do it both traditional and lattice, just so you know. All right, pause the video. Do number 7. Restart it when you're ready. Go. All right, so let's see how you did in number 7. So first, if you're doing it traditional, I have the problem set up over here. When I do it traditional, I multiply as if they are whole numbers. So I'm actually just going to do 204 times 75. If I do it lattice, I actually do a lattice and I write 0.204 times 7.5. Now I'm going to kind of do them both. So focus on what you did. If you did traditional, focus on that. If you did lattice, focus on that. So for traditional, I'm going to start, I'll switch to blue here. I have 5 times 4 is 20. Write the 0, carry the 2. 5 times 0 is 0, plus 2 is 2. 5 times 2 is 10. So my first set of numbers is 1020. But then I need to remember to fill in an empty spot here with a 0 before I multiply the 7 times everything. So now I'm going to do 7 times 4 is 28. I write the 8, carry the 2. 7 times 0 is 0, plus 2 is 2. 7 times 2 is 14. I will be adding those up in a minute, but they're my partial products. So if you did traditional, you can check those numbers out. Now, lattice, I'm just going to multiply. Let me move it here so you can see both to get my boxes. So 7 times 4 is 28. 7 times 0 is 0. 7 times 2 is 14. 7 times 0 is 0. I'm going to do the same with the 5. 5 times 4 is 20. 5 times 0 is 0. 5 times 2 is 10. And 5 times 0 is 0. Okay, so lattice people. You could always pause the video to check and see if you have your numbers right. Okay, so now I'm going to add them up in both sides. So traditional, you're going to get the same answer, by the way, if you did it right. So I have 0 plus 0. 8 plus 2 is 10. Carry the 1. That's 3. 4 plus 1 is 5. Bring down the 1. Lattice, 0. 8 plus 2 is 10. Carry the 1. 2 plus 1 is 3. 4 plus 1 is 5. That's a 1. And that 0 I don't actually need. All right, so I get the same digits. 15300. Now, next, placing the decimal point. If you are doing traditional, you have to count decimal digits. There are 3 decimal places there and 1 place there. Add those together, you get 4 places. So your answer, your product, needs to have 4 decimal places. Okay? Now, in lattice, you can do that too. You can count decimal places, but I think it's a little more fun to have the decimals meet. Ready? So, let me get this. Come on. I'm trying to get the pen not as thick. Okay, so I have 1 decimal here and 1 decimal here. So they make an L right there. And the elbow of the L points right between the 1 and the 5. So you have 1.5300. And last, you can drop those 2 decimals at the end and get 1.53. So up here, at this rate, how many kilograms will it increase in 7.5 weeks? You would say 1.53 kilograms. All right, if you had that right, awesome, you're kicking butt. If you had it wrong, I want you to make sure you pause the video and make all corrections in your math problem. Don't just change the answer. All right, when you're ready, you just restart it and we'll move on to number 8. All right, so now we're ready for number 8. Your job is to do it. Show your work, no calculator, whatever method you choose. Have your answer and a label when you're done. Okay, pause the video, restart it when you're done. Go. All right, so here's what it says. Your fingernails grow at an average of 2.25 inches per year. If they grow at an average rate, you never cut them and they did not break. How much would your fingernails grow in 4.5 years? So what you're going to have to do is take the 2.25 inches that they grow a year and multiply by 4.5 years. So let me get it set up if I'm doing traditional versus lattice. Okay, so I have both problems set up. Traditional, notice I'm pretending it's a whole number, 225 times 45, because I'll place my decimal at the end. Lattice, I have the decimals in my factors. So let's start by multiplying. Ready? Traditional. 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 times 2 is 10, plus 1 is 11. My first number is 1125. Next, fill in my 0. And then do 4 times 5 is 20. Write the 0, carry the 2. 4 times 2 is 8, plus 2 is 10. Write the 0, carry the 1. 4 times 2 is 8, plus 1 is 9. Get ready to add up my partial products. Now, lattice, I'm going to multiply. 4 times 5 is 20. 4 times 2 is 8. 4 times 2 is 8. 5 times 5 is 25. 5 times 2 is 10. 5 times 2 is 10. Get ready to add up those numbers. Okay, now let me add them up. 5, 2, 1, 10. 5, 2, that's 11, 10. Same numbers, 1, 0, 1, 2, 5. Now remember, traditional, this is what you do. 2 decimal places plus 1 decimal place gives you 3 decimal places in your quotient, so it's going to be 10.125. Okay? In lattice, let me have the decimals meet. So this decimal right here, this This comes down, this goes over, they make an L. The elbow of the L points down where the decimal is going to go. So that means you get 10.125. All right. If you have it wrong or made a mistake, pause the video and make your correction. Don't just change your answer. Other than that, guess what? You're done. As always, thanks for watching. Later.